I want you to imagine two departments in the same university. One tracks student schedules, the other tracks the weather. Now, on their own, they're useful, of course, but disconnected. Now, imagine what happens when the systems talk to each other. Suddenly, your planner can warn you about an incoming storm before your outdoor class, or suggest indoor study when it rains. That's the power of integration, and today we'll build a mini version of it. Hi everyone, my name is Andre and today I'll be showing you an example of the system I previously mentioned. In this example, we have two subsystems. Subsystem A is a weather provider system, whereas subsystem B is a smart task planner. As their name suggests, the weather provider subsystem, or WPS for short, connects to OpenWeather's API to fetch real-time weather data, processes it into a structured JSON file, and makes it available for other systems. The Smart Task Planner, or the SDP, on the other hand, allows a user to intelligently manage tasks by reading that data and adjusting schedules or providing contextual advice. Now, in integrating two subsystems, we must first choose between three models: data integration, functional integration, or presentation integration. Each model represents a different strategy for making independent systems work together. For this demonstration, we'll be using data integration, since it allows the weather provider subsystem to export JSON data that the Smart Task Planner can easily consume and act upon. I will demonstrate to you the two subsystems and their integration counterpart. First, I will display to you the weather provider subsystem. No. The weather provider subsystem's job is to get weather data from the internet and then display it after. Depending on that weather data, it creates a suggestion. So this would be the weather data that is taken, moderate rain, temperature, and then based on this data, it displayed a suggestion which is to carry an umbrella, schedule outdoor tasks, and prioritize in their study or meetings. That is the main function of the weather provider subsystem. Now, let's move on to the Smart Task Planner. This would be subsystem B and WPS would be subsystem A. This would be the Smart Task Planner. Its job is to let you organize your tasks so you can do your work and have your day become much more efficient and organized. So, for example, I am tasked by my mother to walk the dog later. So I can just put it in here, walk the dog, walk the dog. And then for the date, we just keep it as is, 28. Now I plan to do this after I do some things. So let's set it to 5 p.m. Just like that. And then you add the task. There, done. Now I suddenly decided to do it much earlier. So how about 4:30? You think? When we do this, it updates the task. So it makes organizing much easier. Yeah. No. As I have demonstrated to you, those two subsystems, the WPS and the planner, are both independent. They can work on their own without the help of another system. However, if you integrate them, you can create a much better system which is much more useful, much more amazing in its own right. So after integrating those, I created this launcher. Now, a recap. I use I use data integration to do this integration because the the planner gets the weather data from the system and displays Suggestion on each task if the user must postpone or continue proceed on doing that task. So to make it much more easier to understand, I'm sorry for my broken English. It's just not. I'm still not that good at speaking. So let's activate the launcher. First, it runs the weather provider subsystem so it can get weather data and then save it into a JSON file. After the WPS has done that, the Smart Task Planner runs, and when its very first startup, or when you first run it, it first gets the JSON file and then integrates that into the system so it can make these suggestions. Like, for example, we have entered walk the dog because my mother tasked me with walking the dog later, 4:30 p.m. However, since it is currently raining in my place, so the system suggested me to postpone doing that task. So you see, the it has definitely become much easier to to organize things with data integration and mm, let's just say that with integration you can create much more useful and convenient functions like this, for example. Now, how about if I plan to ah right, I have a class later at 6 p.m. So again, go to class 6 p.m. See, it displays postponed. However, since the weather has recently cleared up, so much later this will change to cloudy. So perhaps the system will suggest me to proceed, and that's the result of integrating both the WPS and the Smart Task Plan. While developing and integrating the WPS and STP, I discovered several pain points that highlight the challenges of system integration, even in a small prototype. One issue was the data format and schema mismatch. The raw information from OpenWeather's API was too detailed for my planner to use, so I had to simplify it into a JSON file. I also encountered error handling and reliability problems since the WPS would fail if the internet is disconnected, leaving the STP with nothing to read, which required me to add error handling and fallback logic. Also, another challenge was timing and synchronization because the STP must run after the WPS. Otherwise, it attempts to read a file that doesn't exist yet. I also further noticed the tension between coupling and dependence, as even small changes in one subsystem, such as renaming a field, can cause the other to immediately broke, emphasizing the need for careful versioning and communication. These pain points mirror real-world integration issues in schools, HR systems, and finance, where mismatched formats, fragile dependencies, and deployment hurdles can cause serious problems. To conclude, just like those two departments in the university, one tracking schedules and the other providing the weather, our weather provider system and smart task planner shows how independent subsystems become more powerful when they work together. Through data integration, we transform raw information into actionable insights, but we also discover the real challenges of interoperability, mismatched formats, fragile dependencies, and deployment hurdles. These are the same issues that schools, businesses and organizations face every day when connecting their systems. The key lesson is clear. Integration isn't just about linking software, it's ensuring consistency, reliability, and adaptability. By building this mini integration, we've seen a small version of a big idea. Systems that talk to each other can truly help people make smarter decisions.